Hello everyone, I wanted to welcome you to the next edition of the BobCAD-CAM webinar series. What's new in V30 Mill Premium? In today's webinar, we're going to learn about the new Mill Premium surface-based toolpath patterns, walking through examples of each toolpath and ways you can use them. As you know, my name is Al DiPaolo. I'm the voice of the Bobcat After Dark video series. You can find me on Instagram at Al DiPaolo or hashtag Bobcat After Dark. You can also find me in the Bobcat After Dark Facebook group, which if you haven't looked for, I do recommend you take a look. So what are we going to learn today? We're going to talk about the Mill Premium toolpaths. The big focus is really on the toolpath patterns, but we're also going to review the area and sorting options, gouge check, and links. When it comes to the Mill Premium toolpath patterns, there's really just a few categories. We have parallel style toolpaths, a long curve toolpaths, morph, project, and Flowline. So we're going to go through each and every one of them and try to have a really clear understanding of ways that you can use them and what you should expect from them. In addition, we're going to go through the area and sorting. This is going to be the area type, 2D containment, extend and trim, and step over patterns, some of the different options that you have available. Now, I'll also go through the gouge check, talking about gouge check on drive surfaces or check surfaces and different ways you can use that. We'll also go into the links, the retract settings, the link options, and the lead in and lead outs. The Mill Premium is the highest level of 3-axis milling Bobcat offers. There's 6 Mill standard toolpaths, 7 Mill professional toolpaths, and 8 Mill premium toolpaths. If you're a Mill Premium user, you generally are dealing with more complex surfacing type applications, and really it provides the highest level of control and options. Now, as you know, with BobCAD, you can expect fewer steps, better cuts, and more profit. Okay, so give me just a second to get my screen set up. While I do that, just a quick shout out. If you can just say who you are and where you're from so I can see where everybody's coming from, that would be great. All right, we got Doug from Virginia Beach, not as nice as Florida. Thanks for coming. We got John here. We got Raj from Toronto, Roger from the UK. Thank you so much for showing up. Richard in Pittsburgh, Larry in Illinois. We got Tom from Wisconsin. There's Rob from New York. I want to thank each and every one of you for spending some time with me here today to learn about the new Mill Premium software. You know, I really appreciate you taking a moment. John from Palm Harbor. It looks like right in our backyard, so it's great to see each and every one with us here today. Now, today we're going to be looking at the surface-based toolpaths. You know, the first thing that I really want to review with the surface-based toolpaths is the workflow, because the workflow is a little bit different than what we have with our standard mill standard or mill premium or mill professional toolpaths. Okay, so that's the first thing that I want to look at. Now, just so I get an idea of who I'm speaking with today, if you are a version 30 or whatever version of BobCAD you may be running, just go ahead and in the question area, go ahead and type in what version it may be, whether you're a version 29 or version 30. If you're running the premium toolpath or the version 30 Mill Premium, you know, note that as well. I would appreciate it. Okay. All right. So again, the first thing I want to cover is the workflow here. I'm just going to run the stock wizard. Nothing's different about the stock wizard when it comes to the Mill Premium toolpaths. You're in the same scenario here. I'm just going to set up my stock, go ahead and blank this out, and that will get us started. So the first thing is, where is the Mill Premium toolpaths located, right? So where are they located? So if we go into the CAM tree here, you know, these are all of our feature categories. BobCAD is a feature-based CAM tree. No, that does not mean it automatically programs your parts. It means each one of these different categories is a feature that contains your toolpath and your operations. Now, what's a little bit different, if I go into this real quickly, when we're in our Mill Pro toolpaths, our features are based on these wizards, and you have an Explorer view, and then you have like a wizard view, like a next and previous. You also have your dynamic machining strategies, so you can take your available operations and add them to your current operation, so you can apply multiple toolpath features to a single geometry set. Okay. Now, when we look at the Mill Premium Toolpaths, you're going to find them under the Mill Multi-Axis. Okay. Yes, you do still get a wizard style screen. So this is where you're going to choose the type of toolpath that you're going to work with. Okay, these are the surface-based strategies we're talking about: parallel cuts, cuts along a curve; the morphing strategies, morph between two curves, parallel to multiple curves, project, another morph, parallel, and flow line. Okay, so these are your surface-based strategies. Now, when you pick one of these strategies and then you move forward, okay, you posting your tool, when you get to the parameters, this is really where all the meat of these toolpaths are. These are where all your settings are, and you're going to use these tabs across the top of the screen in order to go through and define different aspects of your toolpath. So it's a little bit different than the Mill Pro, where you can use DMS, multi-axis. You don't see DMS, so you do have to load one strategy at a time. Okay. Now, across here, so we have our surface paths. This is generally where, your pattern settings are. Okay, so like when we normally do a Mill Pro toolpath, your patterns determine like the direction or angle of the cut and the style. So you'll see that same section here under patterns. Now, the other thing that you'll notice too is drive surface. When you're in a Mill Pro feature, you'll do a geometry selection. When you're in the surface-based toolpaths, we're going to use what's called drive surfaces. It's really the same thing. It's your geometry selection. Okay. Now, this area here, this area is kind of more like parameters. Parameters are option settings. So these are different options that you can turn on or turn off that will affect your toolpath. And this is where the bulk of your setup is on your toolpath. Now, tool axis control, because these are surface-based toolpaths, depending on like if you're a 4-axis Pro or 5-axis Pro user, you would have access to these same strategies in 4 or 5-axis. If you're a Mill Premium user, you're going to see these in 3-axis only. Okay, so you won't really need to do anything with the tool axis control. Gouge checking is for your gouge checking. Links is where you're controlling what happens at the beginning. What happens when there's gaps in the cut or links. This is also where you're going to set your clearance planes and values. This is under retracts. All of these settings here are going to affect your retracts. So we're going to go through that as well. Your roughing, these are some additional options that you can use. Sometimes they're specialized for specific applications, but you can use these strategies for roughing, semi-finishing, and finishing. So some of the roughing options here will allow you to take, like a single pass and turn it into a roughing pass, okay? And then the last one here is our utilities. And these are, again, just different options that you can use to affect your toolpath. Where we're going to spend most of our time today is in the surface path section in these areas. And then we'll also spend some time, in the links section as well to go over some of these different options. All right, so if there's any questions about where the premium-based toolpaths are located, or if there's any questions about the wizard and the workflow, please let me know. Go ahead and ask. And just as some general housekeeping, any questions that you guys have at any time about the software, just go ahead and type it into the question area. That's how you communicate with me. I am the only person, only staff that's on this webinar. So if you have any questions, just go ahead and type it in there, and it would be great to see what you guys want to know. All right, so that's, again, the basic workflow is we're going to come to our machine setup. We're going to go down to Mill Multi-Axis. We're going to choose which cutting strategy we want to use, and then we're going to go to our parameter settings, and we're going to use these tabs in order to define or edit different settings of our toolpath. Okay, very good. So what I want to look at here, I really want to talk about the toolpath patterns, and I've kind of grouped them into a couple of different areas. So the first group that I want to talk about is going to be the parallel style toolpaths. Okay, so we're going to go to surface based, and we're going to go to parallel cuts. Okay, I'm going to set up a ball mill. I'm not so concerned with the tool size here. And then we're going to jump right into it. Okay, so when you look at this, we have basically two sections here. We have machining angle in X and Y, and we have machining angle in Z. So the first parallel cuts we're going to talk about is machining in Z. So we're going to go to constant Z here. Okay, so this is going to be more of a Z level finish type strategy. All right, we're going to go to our drive surface, and I'm going to select a single surface here. And then I'm going to hit my space bar, and I'm going to compute the defaults. Let me get it to 3-axis, and then I'm going to compute the defaults. Okay, so this is very typical of what you'll see with the surface-based strategies. By default, it's set to single direction. By default, the clearance may not be where you need it to be. So this is very common. And a lot of times what we're going to see when we first start out is a bunch of additional tool motion that we're really going to try to get rid of. Okay, so one of the first things that we're looking at is this is a parallel cut, and this one we're aligning with Z, so this is more of a Z level style. Okay, so let's go back and edit the feature here, and I'm going to make some adjustments. Number one, I'm going to go to my sorting area here. Okay, and instead of it being one-way cutting, I'm going to make it two-way cutting. Okay, so we're going to do a zigzag. All right, the next thing I'm going to do is I'm going to go to my links tab here. Okay, and I want to go to the retract options. All right, so the retract option, this is really like your clearance plane, where the tool is going to go, you know, before and after the cut and in between. There are a lot of options in here. What I'm going to do is just change the clearance type. There are a number of types in here: plane, cylindrical, and sphere. I'm going to go to automatic. Now, automatic is going to push them way up high, but at least I know that they're out of the way. I'm going to go ahead and click OK to this, and I'll recompute. All right, so here we can see our toolpath. All right, this is again a parallel. This is parallel cuts machining in Z. All right, so that's what we're looking at. Now, one of the things that I want to kind of hone in on a little bit is this is my drive surface. So this is the surface that I've selected. You can see the toolpath that is created here. The tool is going to go to the tangency point of that ball. When we see it down here on this final cut, you're going to see how, let me see if I can get to a view here. You can see how the tool is going to go to the tangency point of that surface. And that's really important to understand with the surface-based toolpaths. This is a common scenario that you'll see, and it's actually a really good thing, especially when you're dealing with like rollover and machining these surfaces completely. All right, so this is again a Z-level style. Let me close this. I'm going to go to my geometry here, and I'm just going to add some more geometry. So I'll add these surfaces here, and then I'm going to recompute. Now, again, these are surface-based toolpaths. So, you know, like with a Mill Pro, generally I'm going to recommend you select all of your geometry, and then you'll use containment like boundaries and check surfaces to bring the toolpath in. When you're dealing with the surface-based toolpaths, you're selecting, you know, I don't want to say as little geometry as possible, but really only the geometry that you want to target. And that is really important. Now, another thing that's really important about this too is if we go to views and we go to surface normals do play a role in these toolpath calculations. You'll notice on my model, which for those of you that like to know, this model was drawn completely inside of BobCAD in this particular file. Sometimes I bring them in from SolidWorks. Sometimes I draw them in BobCAD. This one was drawn in BobCAD. you will see the surface normals. These are like the positive direction, I guess is one way of looking at it, the positive direction of these surfaces. And you do, when you're selecting these surfaces, you do want them pointing in the same direction. If you don't, then you'll get toolpath that is cutting on the wrong side of the surface. So it is something that you have to pay attention to. To find your surface normals, you can go to View, and then you can go to Surface Normals to turn them on. You can also turn them off as well. Okay, so here you can see this is a Z-level style routine. I can add some additional surfaces. If I want the tool to go further on down the line, I can add more surfaces, and you can see it generates more toolpath. Now, all right, let me remove these surfaces. Let me grab a different group here. You know, maybe I'll grab this section here. So I'm just going to select some of these surfaces. And again, this is the first type of toolpath. This is called parallel cuts. And then what we've done is we've set it to machine in Z. So I've selected some other surfaces here. I'm going to go ahead and recompute. It'll take a second to calculate, and you can see we're getting a Z level style path. Okay. Now, one of the things new users to surface-based toolpaths that they run into is actually, Gary had a great question, great point. Can you change the direction of a surface normal? Absolutely, Gary. There are some tricks to it as far as like saving out as a file type and bringing it back in to auto set them all going in the proper direction. But for changing the individual surface normals, you can come in here to Utilities and you'll see Reverse Surface Normal. And that's what you would use for surface normal. Okay, very good. So again, we have our Z-level style here. And one of the things that you're going to notice is we're getting a bunch of retract movements here. Okay, these movements that we're seeing here, these are called link moves. And one of the really powerful aspects of the surface-based toolpaths is the control that you have over link moves. Okay, so again, this is a parallel style in Z, so this is very similar to a Z-level finish. If we come in and edit this, I'm going to go to Parameters. And again, the link moves that we see are going to clearance. Okay, so there's basically three groups here. There's our entry and exit, and this is really just about the lead in and lead out at the start of the cut or the end of the cut. Okay, the next one here we have is gaps along the cut. Okay, and this is when there are gaps like holes or there's gaps along the cut, and then we have links between the slices. Okay, so this is when we're linking from one section to another section. Okay, so when we look at this, if we look at our toolpath here, basically what we're seeing is the tool is going to come down. It's going to run around a section of this, and as it goes, it goes to clearance. It comes back down, it does another section, goes to clearance, comes back down, does another section. Here you can see it's doing a zigzag routine because that's what we told it to do. And as it goes from one section here to another section, it's going to clearance. Okay, so what I want to do is I want to go in and edit this. I'm going to go to links. Okay, this is links between slices, and we have small moves set to direct, and we have large moves set to retract to clearance. So what we're seeing here is a small move size, which is in a percentage of the step over, or we can set to this as a value. So this kind of gives you control over, how far the tool needs to move for a link, and give you some options here. What I'm going to say is that, if the link move is within 500% of the step over, just as an example, it's going to do a direct move. So let's go ahead and make this adjustment and compute. It'll take a second, and then what we're going to see is these moves here. See, these purple moves came up. So what these are doing is a direct move. Okay. Now, again, you have these two sections here under links. You have gaps and links between slices, and sometimes I think a link move is a gap move, and sometimes I think a gap move is a link move. So it's a little bit of trial and error here, but as you get through this, you'll kind of see what's going on. I'm going to set this to the same value for our gaps along the cut, and I'm going to recompute here, and what we should see is some of these rapid moves come down. All right, so you can see these are considered the gaps along the cut moves now, and then we're doing some direct linking, so it links from one side to another in order to control how the tool is moving from one cut to another cut. All right. If we go back in here and we edit these parameters, we go to links. Okay, instead of it being a direct move, you could say follow surfaces, you could do a blended spline, you could do a step. So there's a lot of different options so you can control what's going to happen between one of these, as it goes from one toolpath to another toolpath. I'm going to go to the blended spline here, and I'm going to recompute. And so instead of it being a direct move, we can see more of a blended move. All right, so that's a little introduction to the links. We're going to get back to that a little bit later. Again, the focus that I want to have here is, I'm just going to make these direct and direct for right now. The focus that I'm going to have here is really just about the patterns. Okay, so this is the first pattern. Why didn't this the center? I'm not sure what you mean there, Reginald. Maybe you can rephrase that so I can understand. All right, so very good. We have our pattern for Z. Now, what I want to do, and again, I can go through here. I can remove this geometry. I can reselect. I can grab, another group of geometry, whatever the case might be, and then recompute this. And again, I'm applying this parallel cuts in Z. All right. So now I'm going to get into the next one here. So I'm going to come down into my parameters, and then instead of constant Z, I'm going to say parallel. So this one's going to be more like a planar type toolpath. All right. So we can set our angle in Z. I'm going to set it to 90. I'm going to recompute with the surfaces that I have selected here. And here you're going to see more of a planar style. Now, I'm going to broaden my selection, so I'll remove my drive surfaces. I'm going to go to like a top view here. I'm going to window pick all of these surfaces here, making sure that I've selected what I want to work with. Let's get rid of the bottom one there. And then we'll run this parallel type strategy. Again, this is parallel in X and Y. So parallel in Z is going to be more of a Z level finish type. Parallel cuts machining in X and Y is going to be more of a planar style strategy. Okay, so let's see here. Are the links rapids? If it shows up as a dotted line, it would be a rapid move. Okay, Gary. If it shows up as a solid line, then it would be a feed move. Okay, so it could be a rapid or it could be a feed. It depends on your settings. All right, so again, if we come back in here and we look under our parameters, we have machining in XY where we can control an angle. If we set it to constant Z, then it becomes Z level. If we set it to parallel, we can control the angle of the cut here and then compute that, and that would be more like a traditional planar type toolpath. All right, if there's any questions about either of those two patterns, just go ahead and let me know. Again, you do see a bunch of linking movements here, and this is very common. Until you go in and adjust some of your link options, that's going to be more of an issue for you. Again, this is not, it's not difficult to come in here and to handle this. We can go to our links. You can either increase your gap size here, so we'll set these back to 500 and then recompute. Or you can go in and start modifying some of the different settings. Okay, there was a question that Sean had with fixed parallel Z. There's still maybe some scallops depending on the size of the bit. Does this somewhat eliminate the scallops? No, I don't. The scallops that you're going to get is going to be based off the slope of the surfaces you're selecting and then like some of your step over settings. So, using either Z level or planar, Z style or Z level style is going to be best for near vertical shapes. Planar or XY machining is going to be best for more shallow shapes. So you can use a combination of the two of them, and you can use angle ranges to do that. But part of what you're getting with your surface-based strategies are some of the morphing toolpaths that will allow you to tack tapered walls that may taper in two directions, like we see on these locks. Okay, so we'll talk about that some more. Again, here by changing some of my linking options, I was able to knock down some of these link moves that are here, and we could continue to go in and to knock those down. All right, so we have parallel cuts in Z, we have parallel cuts in X and Y, and again, that's Z level finish style. And then we also have more of a planar style. Those are what those two are. Some of you may be saying, well, what would be some of the advantages of using the surface-based toolpaths over the Mill Pro toolpaths? And that really comes down to some of the additional options that you get. The rollover to the tangency point would be a good reason or a good value. But then you also have things like your cut order. You can do center away cutting. You can do outside to center cutting. You have machining by lanes or machining by regions, and this will affect some of the rapids and the reposition. So it really allows you to more surgically go in and edit that toolpath. All right, so we have our Z-level finish. We have our planar style, again, constant Z or parallel. The next one that I want to move into here is going to be another parallel routine. You have parallel to multiple curves, and then you also have parallel to surface. Okay, so we're going to go to parallel to multiple curves here. All of the settings that we've used, we're going to keep the same. We're just going to switch out some of our geometry here. Okay, so we're going to go to our edge curve in this case, and I'm just going to select some curves here. Okay, so those are the edge curves that I want to work with. You can see highlighted, that's my edge curve. And then I'm going to come to my drive surface. I'm going to remove all of my selection, and I'm just going to select this surface on the bottom here. And then I will recompute. Okay, so what this does is it gives me a parallel surface to, or it gives me parallel toolpath to this drive curve. So here's the drive curve that I want to follow. That's kind of like the direction that I want the tool to go. Whatever drive curve that I select, it's going to run parallel to my drive surface. And here you can see it's cutting all along these surfaces here. Now, there's definitely some problems because it's cutting way further out than I would want it to. So how do we control some of those things? All right, so if we get into this parameter setting here, and again, we look at our area type, there are a lot of options in here. And depending on which toolpath you're using, the options can change. What we want to do is go to determine number of cuts. Determine number of cuts allows me to say how many passes I want to make. So in this case, I'm going to say 3 passes, and then I can recompute. Okay, so what this is giving me is some toolpath that is running parallel to my edge curve, and it's running, being driven along my drive surface here. So this could be used to, maybe clean up, some fillets or intersection of surfaces like that. I really like this toolpath. I use it quite often. I find it definitely it's one of my go-to strategies. I use it very often. All right, so let's go ahead and make some changes here. So what I'm going to do is I'm going to remove my drive surface here, and I'm going to select some different drive surfaces here. So I'm going to select those surfaces there, and then I'll remove my edge curve, and then I'm going to select this edge curve here. Okay, so I just want to show you that, using this strategy, you're going to get parallel toolpath driven along your drive surface parallel to your drive curve. All right, so that's what that is all about. All right, so we have, these are our 3 parallel cuts, parallel in Z, parallel cuts in X and Y, and then you have parallel cuts to a curve. If there's any questions about that, go ahead and let me know what you're thinking. All right, the next thing that I want to do, or the next toolpath pattern I want to get into, is really the curve type patterns. Okay, so let me edit this one here. All right, so when we're looking at the curve type patterns, we have cut along a curve, and then we also have project curves. These two are what I consider the curve style patterns. Okay, so when we go to cut along a curve, that's the first one that I want to look at here. You're going to see under the patterns, we're going to have a lead curve or edit curves, and then we're going to have a drive surface. So in this case, I'm going to select this same, actually, let me do it. I'm going to do this one here. Okay, so I'm going to select this curve here, and then I'm going to select let's see, I'm going to select these fillets here. All right, so I have that curve and those fillets. All right, now for this strategy, this is the first one. This is called cuts along a curve. What's going to happen is the toolpath is going to generate a perpendicular toolpath to the lead curve, okay, or the curve that I select, whether it's surface edges or wireframe geometry. I'm going to get a perpendicular toolpath along that curve, and that toolpath is going to be driven along our drive surfaces here. Okay, so let's go ahead and recompute this, and this shows you what we're getting here. So again, this is my drive surface, so that's the surface I want the toolpath driven along. This is my lead curve. The lead curve that I generate, I'm going to get toolpath perpendicular to that lead curve. Okay, so let's remove and remove. Let's do a different section here. So I'm going to select maybe some of these surfaces here. Make sure I don't have this one in the back. Okay, and then for our lead curve, I'm going to select this one right here. Okay, and then we'll recompute that. And again, you're going to get toolpath perpendicular to that lead curve. Okay, and it could be anywhere. It could be anywhere on your model. What's important to understand is that the toolpath that you generate is going to be perpendicular to that curve. So if I do like another section here, let's say I have these two sections, and then I pick this curve right there, I can come in and compute, and then you can see the toolpath that we get to cut along in that area. Okay, can I use this in SolidWorks for BobCAM V6? Yes, you can use the V6. V6 does offer mill premium toolpaths, so yes, you could use these cutting strategies, and the workflow that I'm showing you here would match, except you'd be in the SolidWorks environment. All right, very good. So this is parallel cuts, or I'm sorry, this is cuts along a curve. You have your curve, your lead curve, and you're going to get perpendicular toolpath to that lead curve following along your drive surface. Okay, if there's any questions about that, go ahead and ask. Otherwise, we're going to move on to the next one, the next curve-based toolpath, or what I'm categorizing as curve. So what I'm going to do is I'm going to draw some geometry here. Let's go with 3. Okay, so this is the next one. This is called project curves. You should be familiar with project curves. Project curves is available in the Mill Professional, so it's going to work very similar to that. We're going to edit our curves. So this is our projection curve. So I'm going to pick this circle here. Okay, we're going to there is a max projection distance, but we'll talk about that here in a second. I'm going to go to drive surface. I'm going to clear my selection there, and I'm going to pick this this surface here, which is good. All right. I'm going to set my projection to Z-axis. Okay. By setting it to Z-axis, you're going to see that the max projection distance goes away. This max projection distance is when you're dealing with a projection direction to surface normal, it's how far the projection curves can be away from the drive surface. Okay, when we switch this over to our Z amount, we don't need to worry about that. We do have our cutting either center, left, or right. And then we're going to just do user define, and we'll compute this here. And what we'll see here is the toolpath just being projected down, just like we would get with our projection toolpath in the Mill Pro. Okay, we can do an offset here. We can set the number of offsets. We can set which direction the offsets go in. Again, this is basically the same functionality that you have for project curves in Mill Pro in Mill Premium. Now, what is a little bit different are the 2 additional strategies that you get with project curves. Okay, so when we come in here and we look at our parameter settings, not only can we just do a projection, we also can do a radial toolpath. what I like about radial toolpaths, I mean, generally are a little heavier in code because the tool path doesn't align with like a G18 or a G19. So you get a lot of line segments versus getting some arc segments in there. But what I do like about this particular one is I can come in here and I can pick where the center of it is. And unlike the mill standard tool paths, I don't have the ability to select the center. The center is based off of your work offset. So now you can use a radial tool path because you can pick where the center is. And you can set what the start angle and the end angle is. Let me go ahead and compute this. We should see some toolpath along our drive surface here so we can see how that works. So again, this is another curve-based toolpath. This one is a radial style. You can pick your center, and then you can also, well, picking your center I think is great. And then again, that toolpath is going to be driven along the drive surfaces that you selected. So in this case, I've only selected this bottom surface here, so that's where I got the toolpath. Now, if I had selected the other surfaces, I would get it there as well. If I want to go in here again and edit this, we'll go under parameters. Instead of a radial, you do also have a spiral style, so you can do a spiral style. And again, you also have the offset style. So these are the three different styles here, either user defined, whatever your geometry is, projected down onto your drive surfaces, radial to radial out, where you can pick a center for it and enter a radius, a start and end radius, or you can use a spiral here as well. Okay, so if there's any questions about that, go ahead and ask away. Otherwise, we're going to move on to the next cutting pattern. Okay, so the next one that I want to look at here is actually one of the morph styles. Okay, so we have morphing style toolpaths. These are very popular because of their blended patterns. Okay, how you're going to blend from one curve to the next. So when we get in here, under our patterns, you have first curve, second curve, and drive surfaces. So I'm going to start with the drive surfaces. Let's go ahead and clear the surfaces down here on the bottom. And again, if we look at this lock here, you can see there's a taper, and you can see the height on this side is greater than the height on this side. So when you do a Z-level finish, it starts trimming itself out. You may want a blended path for that particular area. So I'm going to select these curves here. These are the surfaces that I want the toolpath driven along. All right, so those are my drive surfaces. Okay, my first curves, I'm going to pick the top curves here. And you can pick surface edges or wireframe. Either will work. Second curves, these are going to be the curves down here at the bottom. Go ahead and space bar to that. And then we'll compute this here, and we'll see we get our toolpath blending from, you know, one side to the other. All right, so this is a morph strategy, an example of a morph strategy. Now, again, one of the things that you look at with the surface-based strategies is what are some of the additional options or controls you can use. One of them that I think comes in pretty handy is the extend and trim option. I've talked about this for a long time. This is a great way to extend the toolpath off the ends of your part, but you do also have side extensions as well, so you can extend it on the sides. But generally, we'll use this, you know, maybe we'll do like 55% of the cutter. So basically, it just starts off the surface and finishes off the surface. So we can recompute that there, and we'll see how it pushes out on either end. Okay, so again, that is a morph style toolpath. Using a morph style, you know, you can do compound curves, you can do all kinds of stuff. Another thing that's really important too to understand is these toolpaths support undercutting. All of these toolpaths support undercutting. So if you're using a ball mill or a lollipop mill or like a dove mill or a T cutter, if you're using any of those types of tools, the toolpath will have access to each, you know, the top of the balls, etc. Any type of extension to trim in 3D Pro. George, yes, using the toolpath extension in the toolpath editor, you can get some extension in 3D. But you also have to look at the geometry type that you're after. to see what's going to make most sense. A lot of times I'll just extend the geometry. So this is a quick way to extend out your toolpath without having to edit any geometry. Okay, so that's a morph strategy there. What I want to do is get into another morph strategy. So I'm going to remove, and I'm just going to do a different section. Okay, so I'm going to do this section here. Okay, so that radius is what I want to cut. So that's my drive surface. I'm going to do my upper curves, which is going to be here to here to there. I'm going to do my lower curves, which is here to here to here. Okay, and then I'm going to compute this. Now, what I've personally found is that, you know, again, the surface-based toolpaths they're more surgical. You can really go in and target areas of your model that you need to clean up, blended surfaces, compound curves, etc. When you go through and you start editing your settings, like you go into this feature here and you're starting to edit these settings here, there are a lot of settings. I mean, I've definitely spent some time with these dialogues, so I have a decent familiarity with it. But a quick tip that I have for you is once you set up one of these strategies for common cutting routine, go ahead and save that feature because it will save your defaults. The other thing is, as you continue to build in strategies, you can take these and you can copy and you can paste them. So that way your retracts and some of your other settings will carry over, which I think is a very helpful workflow. Okay. And as always, I do recommend you use the folders. You add in a group, and these could be work in progress or those could be cleanup, etc. I think those help organize your CAM tree quite well. All right, so we did our first routine here. This is a morphing strategy. Again, those are the surfaces we want to attack. This is our upper curve. That's our lower curve. We get a morph between it. We do get the tool to roll over at that tangency point. So as it comes through here and it machines these areas, you can see that the tool tangency point is going to go to the edge of that surface there, which is a great thing, okay? Really good at cleaning up those areas of the model. Now, we have another morphing strategy here, which is going to function very, very much the same, but your input geometry is going to be different. So let's look at that. We're going to come back, instead of morph between two curves, we're going to do morph between two surfaces, okay? And that's what you'll see is you'll see like a morph between curves, morph between surfaces, parallel the curves, parallel the surface. And the cutting strategies are basically the same, but the input geometry is what's different, whether it's the curves or the surfaces, okay? So we're going to do morph between two surfaces here. This is going to be the same workflow. I'm going to pick my drive surfaces first, okay? So I'm going to clear my selection, okay? And in this case, I'm going to say, you know, again, it's just a different section here, but I'm going to select these as my drive surfaces, okay? Now, my surface, I'm going to pick this first surface here. So I want to morph between that surface and I want to morph between this surface here, okay? So instead of picking the curves, I can pick the surfaces. When I recompute this here, we're going to see the same morph style to go through and clean up those surfaces there. All right, my step over seems a little tighter, but again, it's the input geometry that was different. If we go back, let's remove. We'll do our drive surfaces as, let's say, here, here, and here, like this section. All right, those are my drive surfaces. This is my upper surface. Okay, this is my lower surface. I'm not sure if I got the radius in the bottom. I did. Okay, so I'm going to recompute this, and then that's going to do a morph strategy between the top surface and the bottom surface. Okay, so again, it's just a different approach to it. Okay, so we did morph between two curves. We did morph between two surfaces. The last style that I want to look at here is really the Flowline style. Okay, so we're going to go ahead and switch this up. We're going to go to Flowline here. We're going to go to our drive surface. Now, the thing to understand about Flowline is for single surfaces. So if I come in here, let's say I select these surfaces here and I want to run a Flowline on it, okay, and I compute this, it's going to yell at me. Flowline pattern needs only one surface for calculation. Okay, so Flowline is going to be used on single surfaces. If we come back in here and we edit, again, we go to our drive surface. I'm sorry. We'll just select one of these, like this radius on the corner here, and we recompute. Let me try this again. Remove, reselect this one, spacebar, compute. All right, there we go. So now the flow line is going to go one of two ways. Okay, so either it's going to go across or along the UV lines. What you have to do in order to change the direction is you can either stay along or around. So if we go to around and we recompute, what we're going to see is the toolpath go along those directions there. Okay, so again, Flowline is really quick to set up. This is a good blending toolpath. It's going to use, the UV lines of the surface in order to dictate the cutting directions. Let me turn this off here. Let's go in and select a different drive surface. So we're going to select this surface here. As such, we'll go ahead and compute that. We can see the toolpath that we get along that area. Okay, so again, these are the main patterns that you're going to get with these toolpaths. You have parallel patterns, machining in Z, machining in X and Y, or parallel to curves. You're going to have, so let me go back in here. So this is your parallel. This is going to give you machining in Z or machining in X and Y. If we go to our parameters, if we have it at constant Z, then that's a Z level style. If we have it set to parallel, then we can control our XY angle. All right, so that's the first one. The next parallel style would be parallel to multiple curves or parallel to a surface. This is going to work very much so the same. We're going to have an edge curve and a drive surface, and the toolpath is generated parallel to our edge curve. Okay, so let me go in and do, another example of that. So we'll say edge curve here. Let's clear our selection. I'm going to go over this edge here. And again, all the selection options that you have. So I can right click on this edge and I can do a loop selection. When I do a loop selection, I need to pick something other than the inside edges here, or the first one. I need to pick one of these other ones that show it going around. If I zoom in, you can see the highlight is on one loop here, and then another loop that goes around. I'm just going to click on the loop that goes around, and that will select all those curves there. When I look at my drive surface here, instead of selecting this wall, I'm going to select this floor surface. Okay. Now I don't want it to cut all the way. I mean, I could if I leave it where it's at now. What it's going to do is offset off from there all the way out. In some cases that may be beneficial. In other cases it may not. What I really want to do is just like a cleanup pass between this floor surface and this boss that's here. So I'm going to come into my area settings where it says type, and I'm going to do limit. Determine number of cuts, and then I can set how many passes I want to take, and then we can go ahead and compute. All right, so that is your parallel cuts to curve. Whether it's to curve or to surfaces, the workflow is going to be the same. Again, we talked about cuts along a curve. This is going to give you a perpendicular toolpath. If we in cuts along a curve, again, you pick your edge curve and your drive surface, you get parallel toolpath to it, or I'm sorry, perpendicular toolpath to it. We have our project curves, which will project down onto your surface. It's also going to give you a radial and a spiral routine, okay? We have our morphing strategies, either morph between two curves or morph between two surfaces, which will morph the toolpath from one curve or surface to the other following your drive surface. And then lastly, we have our Flowline toolpath, which will follow the curvature of the toolpath, okay? So I feel like that's a decent overview of what those strategies are. If you guys, if any of those toolpaths are unclear, can you please just express what is unclear or what you may need to know a little bit more about? I know Dirk's got a question about the utilities tab, so I'll go into that in just a second. Sean has a question. With fixed parallel Z, there may be some scalloping. Okay, so I think we already answered that one. Yes, it runs in SolidWorks. Trim extend in 3D, we talked about extending geometry or using the Toolpath editor. And then Dirk has a question about the tab. Okay, so there doesn't seem to be any questions about the patterns. They seem really clear. Let me see here who we got in here. Where'd you guys go? All right. So raise your hand if you have a microphone. Anybody in here who has a microphone, go ahead and raise your hand. Let's see what we got here. We have John, so let's turn you on. Hey, John, how we doing?
Good, thank you. It's been muted.
Very good. Well, everybody's muted out unless I turn you on, and you got your 5 minutes of fame here. So, John, tell me, are you a Mill Premium user?
No, just a pro, but we just upgraded to version 30, so I wanted to pick up anything I could. I did learn a couple little things to try.
Okay. So I know one of the big questions a lot of people have is which toolpath to use when. My goal of this webinar was really to kind of describe each of these different surface-based strategies and what you should expect from them. Did I do a good job, or how did I do?
Oh yeah, if we were using the premium, then that was very helpful as far as the paths and what everything's going to do when changing certain parameters. It's very good information.
Good, very good. So are you gonna be in next week's webinar, John?
I will see the day and the time, but.
Very good, very good. Anything you'd like to see me cover in webinars, future webinars coming up?
Well, actually, this is the first one, so that we've watched, and we just kind of go by what you say you're going to cover, and if it's something that we can learn from, then we'll definitely watch it.
Perfect, perfect. Well, I really appreciate you joining us with joining me here today, and I appreciate all the feedback. If there's ever anything that I can help with personally, definitely let me know. I don't know if you're a Facebook guy, John, but if you are, go over to the BobCAD After Dark Facebook group and sign up so you can communicate with more like-minded people.
Thank you.
You're welcome, sir. Thank you. All right, so let's see what else we got here. I got a couple other questions that had come in. Does version 30 do tricordial machining? Absolutely, Tony. Version 30 does tricordial machining, what we call adaptive. Bill said I did a good job. Thank you, Bill. John had a question about guidelines for choosing paths for finish, speeds, etc. Yeah, I mean, a lot of times you just want to follow the curvature of the surfaces, and the speeds and feeds that you're going to run is really going to depend on the material and setup and tooling and equipment. So that's kind of a broad range. If you'd like more information about or training about that kind of those kinds of practices or best practices, you can always get together with one of our trainers and do an hour of one-on-one training. Now, Dirk, I didn't forget about you. We do have just a few minutes left on the hour, so I do want to come in. There were some questions in here about some of the utility options. There are some utility options: surface radius-based feed optimization, contact-based feed rate optimization, feed control zones, user rapid feed rate. We have axial shifts to move things down, gradual for all cuts, damping, max angle step. There are, one of the things about the surface-based toolpaths to kind of understand is that there are options in here that are feature specific sometimes. Like when we get into our roughing, you're going to see area roughing. This is generally for impeller style machining, but it can be used in other applications. So some of these options are going to work and not work in certain scenarios, or you'll use them in certain scenarios. There's a lot to cover here, Dirk, so I don't know if I can get into all of it with you here today. If you wanted to pick out one specifically, I'd definitely go over that. Axial shift just basically drops the entire toolpath down. Okay, so a lot of times we use this for like 5-axis trimming type applications, but that's gonna it's gonna move the entire toolpath down in Z. So kind of like using a negative offset or a negative allowance on your surface, but a lot of times what we'll do is we'll drive right to the surface and we'll use the axial shift in order to drop the toolpath deeper. Gradual cuts in smooth surface normal. Let's see. Gradual cuts for all. This has to do with the tool contact points. I don't know. That's probably I'm going to address these with an email to you later, more specific for you, Dirk, if that's fine. Awesome, cool. This webinar is great, but I had to mute for some of the webinar. Is the webinar going to be available for me to rewind? Yes, Michael, the webinar will be available for you to rewind. Everybody who attends the webinar gets a copy of the webinar emailed to them with a list of the Q&A, which is hint, hint, why I pump you guys up for questions so I can make sure to document them and answer them so you have that for later. So yes, you will get a copy of that. All right, so let's see, what else did I want to review here? I wanted to talk about some leads for just a moment because I really didn't address any of my leads throughout this webinar. It's one of the topics that I wanted to cover. When we go to our default lead in and lead out, you're going to see this this option in here. You have the left side and you have the right side. Okay, so the lead in styles, there are a bunch. You have tangential arc. You're going to have tangential line. You can do vertical tangent arc. Those are probably going to be the most common that you're going to work with. If we just do tangential arc, you can come in here and adjust what the percentage of the tool is going to be for the radius. So you can make some adjustments and then you can take it and you can push it over here. So now you have both your lead in and lead out set to the same value. Now, why that's important is when you start to come in and use lead in and lead outs in different sections, when you use your lead in and lead out, it will use your default. So what you can do is set up your default before you start editing those features, and then you can come back and just turn them on. So the workflow generally is get the toolpath laid out on the model first, and then come back and start addressing your lead in and lead out options. There was a question about Matt. Do you have a cheat sheet for hotkeys for a newbie? I have problems drawing in 3D, but I have version 24. I don't have a cheat sheet for version 24 on the hotkeys, Matt. But if you jump up over on the BobCAD After Dark Facebook group, I can share some things with you there. In addition, I would recommend you considering getting some of the newer software because they did add a CAD history tree and a bunch of solid modeling functions over the last few versions. That would definitely make drawing quite a bit easier. Sean has a question. Are there tips and tricks for breaking objects into layers so that they can be milled separately when the object is large on the CNC? Generally, layers don't line up. What I would generally do with that when you're dealing with larger parts that you want to cut in groups is, use a different work offset and a boundary is how I generally do that. Let's see if there's anything else that we have here. Again, I really appreciate everybody spending some time with me here today. There's just a few moments to go before the end of today's webinar. So I just want to let you know how much I really appreciate everybody spending some time with me here today. I know you guys are busy, so it's great that you spend some time sharing it with me. Again, any last questions that you may have, go ahead and ask them now. We will get a video sent out to you guys for this. We will, or I will do the Q&A as well, or do my best to answer any questions that you have. If you are not a mill premium user and you're interested in learning more about it, I do recommend you call in today. There are some promotions that they were running last week that were pretty amazing. I'm not sure what's going on here. Okay, we're pretty amazing. And if you just let them know that Al from the webinar called in, just call the regular number and just say, hey, Al told me to call in. There was some promotions last week that I might be able to take advantage of. They will definitely service you well. So I would definitely do that. Great primer, lots to absorb. Watch again. Yeah, absolutely, Josh. Thank you so much for joining. Yep, absolutely. Again, if you guys have any additional questions, go ahead and ask them now. Otherwise, we'll wrap up and look forward to seeing you guys in the next webinar. Next week, it looks like I'm getting into the 4-axis new features, the adaptive step over, the new rapid options, and some of the drilling optimization for 4 and 5-axis. The next week, we're going to look at the multi-axis improvements. There's a bunch of things that are done there. Really just a few more categories to go, and then we'll be done with the what's new in V30 and start getting into new topics for the webinar. So again, I appreciate everybody's time. Until the next time, we'll see you then. Thank you so much.